for a chat, Marian. Hello, Marian.
Hello.
Marian, we've known each other a long time, haven't we?
Yeah, since 2018.
Brilliant.
No, no, earlier than that, I think.
Yeah, maybe.
Yeah, maybe.
And you're talking about CLIs.
Yes.
And this is a subject I find very interesting. And one of the things I notice is with command line interfaces, people think it doesn't have a UI. They think it doesn't have a user experience because it doesn't have a web page or it doesn't have a GUI that you interact with. But there is still a user interface there, isn't there?
Yeah, it's a text-based interface between a human and a computer. It's not graphical, but it's text-based, and also it's important to think of, how a user can respond to the output that you're sending the user. So.
Yeah, because I use that oh my ZSH thing, and every time it says, do you want to update? And it says Y or N, and I hit definitely I get it wrong, and I'm just like P, and then it's just like, okay, no update today. I'll try again tomorrow. So yeah, you do have to think about that user interface the same, don't you?
Yeah.
Well, we're very excited for your talk.
Okay.
I think you might have to do some jiggity-pokery on here to make it work.
All right, it's that one.
Yeah. Hey, look at this. We're doing it. Computers. Brilliant. Okay.
Who's got the clicker? All right.
Okay, thank you. Give it up for Marian.
So, not sure how many of you have read my bio, but I have been coding in Go since 2014, so for the last 8 years. But much more than that, I have been playing with the command line interface ever since I was a kid. I was lucky enough to have access to computers in the 80s, and in the mid-90s, my dad actually gave us a personal computer for the house, and I was enamored. I read the MS-DOS manual from front to back. We didn't have social media that we have today, so instead, I would dial into BBSs where everything was text-based. Chat rooms were text-based, games were text-based, and I fell in love, and let's just say the rest is history. So today, it is my pleasure to talk to you about a topic that combines both of these, specifically reinventing the command line interface with Go, from machine-first design to human-first design with an empathetic approach. So the first question you might have is, what is a command line interface, or what is a CLI? A CLI stands for Command Line Interface. It's a text-based interface between a human and a computer. Text is usually input via a keyboard, and then output to a terminal, or piped into another command. But it's a lot more than that. From the 1950s, the teletypewriter, short for teletypewriters, TTY, and it was the main form of communication between people. And this is a timeline that takes us from the TTY to the GUI in the 1980s. A bit of that history has carried over into today. If you are running Unix or Linux on your machine and you open up the terminal and type TTY, then it'll output the file name associated with the standard in. And if it's not, it'll say not a TTY. So there's many usages for a CLI. For example, it's an additional offering to a web API. Many cloud infrastructure companies do this. For example, AWS, Google Cloud, Heroku. And there are tools for increased productivity, such as JQ for JSON parsing, HTTPy, which is a command line HTTP client, PBCopy for copying standard input to a clipboard. Then there are dashboards, which is Qbox, a dashboard for Kubernetes, and Docker dashboard, which is similar for Docker. Then there are command line games. So just a quick note, Space Travel is a game invented by Ken Thompson in 1969. And the porting of that actually spurred the development of Unix. So we can thank games for Unix. So why use Go to build a CLI with Go? For many of the reasons why we love Go to begin with. For example, it's very performant. So we can use channels and Go routines to build a very fast application. Then there's simple syntax of Go, which I think is lended to from the fact that Go has a very strict rules associated with it. And then the cross-compilation aspect of it, it's very easy to cross-compile your Go code to different operating systems and architectures. And then now there are many supportive libraries, such as Cobra, Survey, and TermDash. Cobra is a framework for building modern CLIs, and it even has a CLI associated with it for generating the scaffolding for your CLI application, as well as the commands. Then there's Survey, which allows you to have a Q&A sort of session with your user, and TermDash, which allows you to build terminal dashboards. So at the end of my talk, I'll provide links for all of these packages. And within this talk, I'm going to be going over some examples and the amazing things that you can do with these. One final reason why Go is a great language for building your CLI, I think, is because of its philosophy. So I think it's associated with the Unix philosophy, Go philosophy, which has also carried over into the CLI philosophy. So as many of you probably know, Ken Thompson was co-creator of Unix and Golang, and then Rob Pike was co-creator of Go, but also was a member of the Unix team. So I think that philosophy kind of carries over. And I'm going to be going over some of the major tenets, and following the tenets, I'm going to be going over some of the guidelines. So first, create a modular program. Think about building one application that does one thing very well. That's a very common Unix philosophy. Once you do something that does one thing very well, then you can compose these together to solve more complex problems. Next, keep it simple. So this is kind of related to the first tenet, but more than that, within the application itself, if you kind of think of the common command names and flags and reusing those, that'll make it a more intuitive application for your users. Build for humans first. So if you think of some of the common Unix commands, think of MV or CP. When you type these into your application, you notice that there's no output. That's because a lot of the earlier applications were built for machines first. And that's not what we want to do today. We want to be able to communicate with the user whether or not the application was successful or not. And then save time. So I think the Cobra CLI does a really good job with this. The Cobra CLI generates code for the user, so it generates the scaffolding for the application as well as the commands. So when you're building your application, think of how you could generate code or generate configuration or generate something for the user to make their life more simple. Next, be transparent. So if you're doing anything outside the bounds of your application, like downloading a file from a remote server, or let's say modifying files locally, then notify the user, let them know, even tell them whether or not they want this to be done and give them the ability to decline if possible. Be robust. So if you are following these tenets and guidelines, I think you will build a more robust application. But just in general, when you're using a CLI, you don't want to feel like it's crumbling when you're using it. You want it to feel sturdy. And I'll give some tips on how to build a more robust CLI in a bit. Be succinct, so rather than just saying everything to the user, just communicate but keep it brief. No surprises, so whether or not the command for the application was a success or failure, you want the user to know exactly what happened. So communicate that. And if there's an error, fail noisily. Build a prototype, then optimize. So think of the minimal viable product approach, and think of what are the minimum number of features that you can add for your CLI before you can put it in front of users. And that way, the sooner that you put it in front of users, the sooner you get feedback, and the faster you can optimize. Next, build flexible programs. So users may not use your application in the way that you expect them to. So give them different options for how to do one thing. And if they do something that's unexpected, provide them guidance on how to do it the correct way using your CLI. Next, design for extensibility. So this is a bit of future-proofing for your CLI. You want to build in a way that is easy to extend upon in the future. And then be a good CLI citizen. So just like we are a community of Gophers here, when you start building CLIs, you're going to be within a community of other people building CLIs. So following these philosophy tenets and guidelines will help you to be a more good CLI citizen. So let's start with some of the guidelines. First is naming. The most important thing is to keep your name simple and intuitive. The first two examples here use a play on words, which I think are really fun. ImageMagick, for example, is a tool that allows you to compose and edit and modify images, supposedly create magic on these images. So I really love that, and I think that can get the point across really easily. And then there are tools that are very simple as well as intuitive because they match the name of the web API associated with it. Next are some guidelines for input. So commands, arguments, and flags. Think of the way that we communicate with each other with language. In the same way, we're going to be communicating with a computer and using language and syntax and grammar. So this is just an example of the common way that we can communicate with our users with a command line interface, where first comes the application name, and then the noun, which is typically the argument, the verb, which is a command. Think of how you can command your dog to, jump or sit or beg. Typically, commands are verbs. And then flags are typically adjectives. Think of just a descriptive element to the command. The noun-verb sequence can be swapped to verb-noun, and there's no hard and fast rules. You can do it either way. But to kind of drill this in a little bit more, I've just listed a couple of examples. So first, let's take the example of Docker, where container is the noun, ls is the verb for list, and then quiet is the adjective. Notice how ls is used. It's a common Unix command, and utilizing a common command within your application, I think, just helps to make it more intuitive. The following line actually switches the order from noun-verb to verb-noun, where clone is the verb or the command, and then the SSH URL is the noun, and then verbose is the flag. And finally, there is a kind of example that does something a bit unique, which is noun, verb, noun, and then the adjective. So these are just examples to guide you on what potentially your command may look like. So here's some generated code from Cobra. I simplified it basically to make it fit on this slide, but the command is set within the use field of cobra.command, And then the args are passed in within the second parameter of the run function. And then flags are set within the init function. Make sure that you add the flags to the command before that command is added to the parent command. These are some additional guidelines for input. First, for flexibility, it's very important to utilize flags more than arguments because it's much easier to add and remove flags than it is to add and remove arguments. And then finally, use common flags and commands when you can. This just helps to make your application more intuitive for your users. Then there's another type of input. Think of the fact that when you're running an application, sometimes it might stall, and you want to Control-C out of it. Well, handling that can build a more robust application. And here's some code to do that. So this code specifically handles exiting the code gracefully when the signal interrupt is received. So after the signal is received within the C channel, that's where you would add the code to exit gracefully. And then you can exit. This block of code is typically added to your main function. Also, for the signal.notify function, the third parameter, the syscall.sigint, you can actually replace that with any sort of signal, as well as a slice of signals. So this is just specific to Control-C, but you can do that for any signal you like. Then there's interactivity. So think of a conversational flow between a user and a computer. That's what we'll be going over today, as well as dashboards. That fits into interactivity. So first, do this for humans only. And I will share a block of code to check whether or not you are outputting to a human or interactive terminal or not. Give the user options. So if they don't want to be in an interactive session, then allow them to use the no input flag to either disable it, which is a common flag, or if they're in a terminal dashboard and don't want to be within it anymore, give them some sort of key to escape, like the Q key. And then if you're requesting any confidential information, hide that information from the screen. So here is just some very simplified code that uses the survey package. Questions is a slice of survey.question, and then answers is a struct with the fields to receive the answers. And then survey.ask takes in the questions and a reference to the answers. Notice that the name of the first question matches with the field within the answer struct. If those two didn't match, then we'd need to add some extra code to handle the mapping. And then the prompt field basically states the type of input that we would be receiving. So for this, it'd be just text input, but the survey package allows you to receive many different types of input, including select or multi-select and many more. So the question here is, what do you say to someone who wants to learn Go? Anyone know? Go for it. All right, so for some of you who are new to Go or are here because you're curious, I say go for it. It's my favorite language, and it might be yours too. And you have nothing to lose and much to gain. So here is an example of a terminal dashboard that is built entirely with Go, which when I discovered it, I thought was really amazing. So TermDash allows you to build dynamic dashboards, and you can build it with a binary layout or grid layout, and then within the layout, you can actually add many different types of widgets that you can see here, including buttons and scrolling text, bar charts, line charts, donuts, and progress bars. Also, you can have periodic and event-driven screen redraw, and also process mouse and keyboard events. And Termdash supports terminal resizing as well. So if you have a chance, I suggest checking out this package and playing around with it. It's really easy to use, and it's very exciting to have something like this written in Go. And as I mentioned earlier, that block of code that allows you to check whether or not you're outputting to a terminal or not, this is it. And that's it. So for output, just think of the fact that when you run a command, sometimes there is this long wall of code and you don't know what happens. So it's very important to have some guidelines around output to be able to communicate succinctly with your users. And here are some guidelines. So in general, for success, always exit with 0. For failure, non-zero. Display output, but keep it brief. So in general, you don't want anything to get lost in the noise. You want to communicate whether it's a success or failure, but think of that signal-to-noise ratio. Communicate state and state changes. I'd really like to call out Git as a really great example for this, and the fact that when you run a Git command, it tells you not just what the current state is, but it suggests next commands for you to call. Also with Git status, it tells you the current state. Use color with intent. So, whether you're encountering an error, I think outputting in red really helps the user to understand that a failure has occurred, and then green really helps a user feel at ease that the command ran successfully. However, it's really important to be inclusive of people who are colorblind, as some of you may be in the audience. So provide some sort of colorblind mode for them. Catch and rewrite errors. So rather than just sending these errors directly to the user where errors might be a bit cryptic, it's really a good idea to rewrite these in a more human-readable format, and that'll help guide the user and make them feel more supported. And then make sure that important information is at the end, because in general, when a command runs and all this block of code is output, our eyes generally focus back at the prompt and at the bottom of the text. So help and documentation. There are many types of ways that you can support your users with help text, man pages, externally hosted documentation. You can provide ways to support your user by giving them an easy way to submit bugs if they encounter one. And here's some code that basically generates the man page using a Cobra command. The short field is typically output when a user runs help on the root command, and then the long field is output when a user drills down and runs help on the subcommand. And thank you very much for being with me today and being a part of my talk. I really appreciate it. I hope you learned something today with these packages, Cobra, Survey, Termdash, and have inspired you to build your own CLI. So if you have any questions, feel free to email me, reach out to me on Twitter. I'm actually working on a book on reinventing the CLI with Go. So if you follow me on Twitter, then I'll be posting updates on it. All of my demo code is available on my GitHub page. The CLI guidelines is not related to Go, but general CLIs, and I highly suggest checking this site out. And then as promised, all of the links associated with the packages. So thank you very much.